All right, for the start of 8-3 notes, so we're going to turn into, to move on to doing a rhombus. And so why don't you quickly, a rhombus, if you think about the hierarchy picture again, is another specific type of parallelogram. So why don't you quickly at least think through your 6 properties that you know I'm going to ask you for. Again, we want to try to do them in order just to help us memorize. Think about your properties and go ahead and think about listing them, and then we'll do them here together. All right, so let's think what you've gone through. So first of all, I hope you're telling me you've got 2 sets of parallel sides. You can tell me the opposite sides are equal. Opposite angles are equal. There we go. Consecutive angles are supplementary. Okay, just for a review, when you draw in one diagonal, it creates 2 congruent triangles. And then something about the diagonals. We need to know that diagonals bisect each other. So again, we're going to use these 6 characteristics, properties, to say these make up a parallelogram. Okay, which I'm going to get rid of this. Just going to abbreviate since I don't have the total room to do that anyway. Okay, so parallelogram. Now again, just like when we did the rectangle, right, we need to have some other specific properties that turn this into now a rhombus. Okay, and there are now 3 more characteristics and properties that do that, hence the last 3 lines. So again, I'll change colors. I'm not going to use the colors I did for rectangle because they're not directly related to each other. Okay, so in a rhombus, more specifically about the sides, not only are opposite sides equal to each other, okay, so let's say we had originally said this, right? Opposite sides are equal to each other, but now we're going to change it to all sides are equal to each other. So we'll just say all sides equal. That means over here, I'm now going to change it so that I have 2 marks on all of them. Okay, so all those sides are equal. Likewise, there's something more specific about the diagonals. Okay, and the diagonals are, what's that symbol again? Perpendicular. Remember when I see that symbol, I think of those 2 things meeting at right angles. That's how I think of it. All right, so now I'm going to draw that in. That means if I draw this diagonal and this diagonal, anytime I know it's a rhombus, immediately you're going to see me put a right angle there, and a right angle there, and a right angle there, and one there. That means basically you're just going to see me kind of draw like this box-looking thing in the middle, if you will. Okay, but what I'm drawing in are the 4 right angles that are there in the middle. All right, and the last thing is also about diagonals. Okay, so now you need to know that the diagonals now bisect angles. Okay, so what we mean by that, I'll put these in here. I'm probably going to erase them just so you know. But if I just take something to mark in here, well, this diagonal that's going from A to C, it's bisecting this angle. So this part would equal this part. And likewise, this part would equal that part. Okay. Now, the other diagonal is going through a different set of angles, so don't make them the same markings, but it means it would bisect through this whole angle and turn both of those parts equal to each other, and likewise, both of those parts equal to each other. Okay? All right, maybe I'll go ahead and leave those in the picture for you, if that's going to help. All right, so adding those 3 properties then, these 3 properties are what turn something into a more specific parallelogram called a rhombus. Okay? Again, remember, in the pictures, I either have to give you enough markings to tell you it's a rhombus, or I have to just say it's a rhombus. Okay? So, once again, all of these are rhombi. Okay, that's the plural of rhombus, but I'll just say that each of these is a rhombus. And here's the information that I want to give you. Let's say solve for x and BC. And I am just going to use just this first picture on the left, okay, for this one. So for this given information, let's give you 3x minus 1 and 2x plus 4. Okay. All right, so what equation could I set up, and what's the property I'm using to solve for x? All right, so we'll just start. 3x minus 1 equals 2x plus 4. I'm always watching for my bigger x on the left since that's how you guys seem to like it. And if I subtract 2x from both sides, I'll have x. Add 1 to both sides, I'll have 5. What was the property I used? Why do I know those two are equal to each other? Well, again, that's because opposite sides are equal. Okay? All right, I'm supposed to solve for BC. Well, notice BC is not labeled. And in a parallelogram, I would have hoped AD was labeled, right? So I could say opposite sides are equal. Well, I don't have that this time. But I should recognize that BC would equal AB. It could just as easily have equaled DC. It doesn't matter. Okay? And therefore, I'm just going to plug and chug. I'm going to say 3 times 5. Remember, we put that in with parentheses, minus 1. And therefore, BC equals 15 minus 1, so what? 14. And what was the reason that I can say BC equals AB? Well, that's because in a rhombus, all sides are equal. That's the property that I am utilizing for that. Okay. All right, let's go down and use this picture here. And if you don't see something in the picture, guys, look around it. We're probably giving you information like in this one. I'm giving it to you outside the picture. So in this one, I'm telling you that AC is 18. BD is 24. And I'm asking you to find AB. Okay, side AB, segment AB, however you want to write that. All right. So, all right. AC is 18. Well, I claim that means that A to the middle then would be 9. This would be 9. And BD being 24, that means each of them to the middle would be 12. And remember, I'm going to write down my property Y. Why do I know that? Well, that's because diagonals bisect each other, right? So I might as well start that. I'll say diagonals bisect each other. Okay, I'll just leave that there for a moment. And I now need to find AB. Okay, well, here's what I notice. There's AB. And me, guys, just so you know, automatically, immediately, when I see diagonals in a rhombus, I do this. I think this is the best thing you could do, is put in those right angles. Because what I'm hoping you see are 4 right triangles, 4 small right triangles. I'm focused in on this one. If they want me to find AB, I'm going to focus in on this right triangle right there. Okay? And so here's the work that I know. I know that if I reduce this by 3, this side's 3, this side would be 4, and now that's a triple. This is a 3, 4, 5 right triangle. I'm asking for the actual length of AB, so I have no choice but to take the 5 remultiply it by the 3 that I reduced by, and say, well, I know that this length is, I guess it would be a purple length, right, to match the others. I know it's 15. The reduced are the 3, 4, and 5 that are in blue. The full lengths, though, are really the 9, the 12, and the 15 that are in purple. Okay, so what we just found was that AB equals 15. So go ahead and box it. But now I needed other properties. Diagonals bisect each other. And the other one that I used, right, that I had to do off the bat, why did I put in the box or the right angles? Well, that property was because diagonals are perpendicular. Okay, and you can just use the symbol just like we did in the notes. And therefore, that's your backup and your reasoning as to why that happens. Okay? All right, we're getting lots and lots more properties, so try to keep those straight. And then we will now move on to another shape.